Let's do a small experiment of finding out specific heat capacity of iron ball. In this experiment, we are going to use a calorimeter. First, we take about 150 ml of water in a calorimeter and measure the temperature. Here it's 27.6 degrees Celsius. Then we take an iron ball, which is about 35 grams in this case, and then we heat it. We measure the temperature of that iron ball, and it's about, in this case, 118.5 degrees Celsius. And then we drop this iron ball into the calorimeter filled with water, and post that we measure the temperature, which is in this case it is 35.6 degrees Celsius of the mixture of the iron ball and the water. Using these measurements, we will try to measure the specific heat capacity of the iron ball. So let's get started. So here is information represented in the form of a diagram. In one of the previous videos, which I will put a link to in the description, we found out that the heat capacity of this calorimeter was 22.7 calorie per Kelvin. So with this, let's try to find out the specific heat capacity of the iron ball. Before we do that, let's find delta T. So here the delta T is 8 degrees Celsius, and here the change in temperature delta T is 82.9 Kelvin. All right, we know that there is a net heat gain by the water and the calorimeter. So gain, and the gain is delta Q calorimeter plus delta Q water, and that's equal to the loss, and that is delta Q iron ball. Let's frame the equations. This is calorimeter would be C dash into delta T plus MC delta T of water equal to MC delta T of iron ball. Substituting the values, we know C dash, which is 22.7 calorie per Kelvin, into delta T is 8 here, because the difference in temperature is 8 even for the calorimeter. Kelvin, because it's delta T, it could be Kelvin or Celsius, they are the same thing, plus M, which is mass of the water, which is 150 milliliter is 150 gram. So 150 gram into 1 calorie per Kelvin gram into delta T is 8, and that's equal to MC delta T of iron, which is 35 gram, into C is something we don't know, and delta T is 82.9 Kelvin here, as you can see here. So if you calculate this, you will get C as 150 into 8 plus 22.7 into 8 divided by 35 into 82.9, and this happens to be 0.48 calorie per gram per Kelvin. This value of specific heat capacity is very close to the actual. So the actual C for iron is 0.44 calorie per gram per Kelvin. As you can see, this is pretty close. So thus we find out the specific heat capacity of the iron ball. So I hope you enjoyed this video. See you in the next one. Ciao.